Written in bone, Buried Lives of Jamestown and Colonial Maryland, Sally M. Walker. Chapter 2. How old were you? A person's age at the time of death is one of the first things forensic anthropologists try to determine when they examine remains. When Ousley knelt on the soil next to JR1225B's grave, he began his investigation by considering the length of the long bones on the skeletal arms and legs. Long bones grow from a person's birth until the body becomes fully mature, around the time of young adulthood. For example, the femurs of the same person compared at ages 2 and 12 are likely to have almost doubled in length. In the case of JR1225B, the length of the long bones quickly told Ousley that the skeleton was not that of a very young child. To obtain a more precise age estimate, he had to look closer. Long bones have two main parts: the shaft, the long straight part of the bone, and the epiphyses, the bony caps located at the end of long bones. Epiphyses remain separate from the shaft during an individual's growth years. In skeletal studies, they provide an important clue to the age at death. Until the age of about 14, a living person's epiphyses are joined to the shaft by cartilage, the same flexible connective tissue found in the tip of the nose. Over the course of the teen years, the epiphyses and shafts of the various long bones start to fuse together, and the cartilage between them is gradually replaced by bone. At this stage, a visible line remains at the places where the epiphysis and the shafts connect. When a female reaches the age of 14 to 18, the epiphysis begin to fuse solidly to the shafts. The line where the bones have fused together disappears at the teen ages further. The epiphysis of a male's long bones fuse 2 or 3 years later than those of a female. This fact would come into play when Ousley later considered whether the bones were those of a male or a female. An inspection of the skeleton's long bones revealed that the epiphyses were still unfused, a definite sign the individual was a teenager at the time of death. Teeth also provide important clues about a person's age at death because they appear at fairly predictable times in all humans. A newborn infant usually has no visible teeth, but they are beginning to form in the jaw, below the surface of the gum. By the age of 2, the child has about 20 visible teeth, often called baby teeth. Children lose their first baby teeth when they are 5 to 6 years old. At this age, they get their first set of molars, the large flat teeth at the back of the mouth. The caption and picture on page 28. To determine JR1225B's age, Doug Ousley examined the upper leg bone. The bone on the left belongs to JR1225B. The bony caps at the end of the bone were not fused to the long part, indicating that JR1225B was still a teenager. The leg bone on the right belongs to a fully mature person. All parts of the bone have completely fused together. And then the caption and the picture or illustration on page 29 says human tooth development by age. And on the left side we have a typical child, 2 years old, and then on the right side a typical adult, 25 years old. The second set of molars grows in at about 12 years of age. A person's third and last set of molars, often called wisdom teeth, grow in at about 18 years of age. The presence or absence of these various kinds of teeth helps a forensic anthropologist estimate the person's age. JR1225B's teeth supplied additional support for Ousley's theory about the boy's age at death. The second set of molars had grown in, and the cusp, the ridged points on the tooth surface, showed signs of wear. During colonial times, the corn and wheat used in everyday meal preparation were not ground as finely as they are in modern factories, so those people commonly ate larger pieces of grain than modern people do. Because this grittier grain was harder on the teeth, it noticeably wore them down. This type of wear is not seen on teeth in modern times. The wear on JR1225B's molars indicated that they had been used for a few years. The wisdom teeth, however, were still inside the jaw sockets, a sign that the teen was younger than 18 or 19 years old. The picture and caption on page 30. To further determine JR1225B's age, Ousley also looked at the teeth by X-raying the jaw. Ousley found that the wisdom teeth had not yet come in, but that the second molars were worn down. This evidence placed JR1225B's age at the mid-teens. He or she. After determining the age of a skeleton at the time of death, the next question the forensic anthropologist tries to answer is whether the person was male or female. In the case of early Jamestown, the historical record tells us that all English colonists who arrived in 1607 were male, but a number of women arrived the following year. Since JR1225B could have been buried at any point within the 20 years James Fort was used, the remains could have been either sex. In adult-sized skeletons, an individual sex is determined based on variations in the pelvis. An adult female's pelvis is shaped differently from a male's, allowing room for an infant to pass between a mother's pelvic bones during childbirth. The picture and caption on page 31. Differences in the shapes of certain bones help forensic anthropologists determine a gender. A notch called a sciatic notch is wider in a female's pelvic bones, left. Certain areas of the male skull are more prominent than corresponding areas on a female's skull, below, left. A male's long bones, such as the upper arm bone, are usually larger and more robust than a female's, below right. These kinds of differences enabled Ousley to determine that JR1225B was a male. Also, the hip bones, which are part of the pelvis, are shaped differently in women than in men. Although JR1225B wasn't an adult, the features of the skeleton's pelvis were distinctively male. Other skeletal evidence provided further support for this theory. A male's long bones are usually longer and more robust than a female's of similar age. Men often have teeth larger than women too. JR1225B's remains met these criteria. Perhaps most conclusive were features Ousley found on the skull. The back of a male's skull, where a muscle is attached during life, has a larger ridge than a female skull. Males also have a more prominent brow ridge, the bony part of the skull above the eyes, than females. The chin tends to be more squared in males, while a female's chin is rounded, with the center of the chin tending to come to a point. The ridge at the back of the Jamestown teen's skull, a slightly heavier brow ridge, and a squared chin were characteristics of a male skull. This evidence, along with the evidence along with that of the other bones, made Ousley feel confident in asserting that JR1225B was male. Where did you come from? Another step in unraveling the mystery of a set of human remains is to try to determine the individual's ancestry. All organisms, including humans, adapt to their environment in ways that make their survival easier. Parents pass along these adaptations, including physical traits and characteristics such as skin color or hair texture, to their offspring. While each person is unique, over many generations, some traits may start to occur in recognizable patterns. In the modern world, people from many geographical areas travel far and wide, building new cultures and starting families, sometimes with people whose ancestry differs from their own. In the colonial Chesapeake region, though, people came from three distinct ancestries: African, European, and Native American. Certain features of a person's skull can provide clues about which population a skeleton may have belonged to. This information can be critically important to helping us understand how people lived in the past. That said, forensic anthropologists always keep in mind that each person is an individual. A given population may include many variations in bone features, and circumstances such as diet and disease may also affect the appearance of bones. Thus, it's important not to rush to conclusions about an individual's ancestry. The picture and illustration and caption on page 33, comparing skull features of three distinct Chesapeake groups. African. Rounded forehead, wide nasal opening, slight overbite, front of jaw, forward of chin. European. Narrow face, narrow nasal opening, slight overbite, front of jaw aligned with chin. Native American. Flat-faced, no overbite, cheekbones project farther forward. Page 34. Schmidt left and Hudgens measured JR1225B's remains in situ. When Owsley began his study of JR1225B's skull, he looked for specific characteristics in the nose, cheeks, and jaw. For example, many, though not all, people from Africa and their descendants tend to have wide nasal openings and a rounded forehead. The front of the jaw often protrudes farther forward than the chin. Europeans and their descendants usually have a narrow nasal opening and a narrow face. The front of the jaw is usually in line with the chin. Native Americans and their descendants generally have a flatter face than either of the two groups, with cheekbones that project further forward. The front teeth of Africans and Europeans usually close together with an overbite, meaning that the upper teeth are slightly in front of the lower teeth. People of Native American ancestry don't tend to have an overbite. When the mouth is closed, the upper and lower teeth usually meet edge to edge. Even slight differences in the shape of the bones that form the roof of the mouth can help identify whether colonial period remains were African, European, or Native American. Ultimately, it's a combination of observation, laboratory testing, and precise measurement that enables forensic anthropologists to decide upon the most likely ancestry of a particular set of remains. Even without all these tools, however, Owsley could see that JR1225B's skull features, the narrow nasal opening, the narrow face, and the shape of the bones of the roof of the mouth were likely those of English people of the 17th century. Using these criteria, Owsley determined that the teenager buried inside James Fort was European. Owsley concluded his initial examination of JR1225B by asking Hudgens and Schmidt to measure the full skeleton and the long bones of the legs. We measure bones in situ for many reasons. At Jamestown, I've got to measure in place, or I'm not going to get the measurement of the whole bone, Owsley explained. Poorly preserved bones, which are common at Jamestown due to the clay subsoil, often crumble as they are removed from the grave. The fragments may be reassembled in the laboratory, but they won't exactly replicate their appearance and size in the grave. Next, Owsley took a closer look at the arrowhead Hudgens had spotted. It could have remained so close to the boy's femur without decomposition only if it had been deeply embedded in his thigh muscle. Although many more colonists died from starvation and disease, some colonists died from wounds received in skirmishes with Native Americans. Had the boy died as a result of such wound? Owsley's opinion was that the boy wouldn't have died immediately of the wound. It was in a fleshy area of the leg where a major blood vessel wasn't likely to have been severed. However, infection was common in the colonial Chesapeake region due to the lack of medical knowledge about cleanliness and the care of wounds. If the boy's wound had become infected, harmful bacteria would have quickly spread throughout his body, resulting in blood poisoning. A fast-acting infection of this sort can kill a person in a matter of days and does not leave traces in the bones. Further analysis of the boy's bones in Owsley's laboratory would supply information about the boy's life and death, though whether it would solve this particular puzzle remained to be seen.